Hi, fourth grade. We're back for our second lesson for this week. We're going to be doing Module 11, Lesson 4, Generate Equivalent Fractions. It starts on page 279, so please have that in front of you with a pencil ready to follow along as I teach you the lesson. All right, so let's go. So when we're done this lesson, you'll be able to use multiplication and division to write fractions that are equivalent to a given fraction. Remember, equivalent is the same as equal, right? And this time we're going to use multiplication and division because remember, division is the inverse of multiplication. And last time we were multiplying the top and the bottom by the same number. Sometimes you can also divide the top and the bottom by the same number to find an equivalent fraction because multiplication and division go hand in hand. So Karen is mixing organic fertilizer for a garden. She needs to add 3/4 teaspoon of fertilizer to water, but she only has a 1/8 teaspoon measuring spoon. How many times does Karen need to fill the 1/8 teaspoon measuring spoon? So what is the information we want to know from this, right? We need to know how many eighths are equal to 3/4, right? Because she only has a 1/8 teaspoon measuring spoon. So we need to know how many of these is she going to need to fill up to get to the 3/4, because we know the label's the same, right? Teaspoons, we know that they're both teaspoons, so we can find an equivalent fraction to figure this problem out. So that's our first thing that we want to know, right? We want to know how many eighths are equal to 3/4. So if we fill out this little part over here, we know that the fraction that we know is 3/4, right? And the denominator of our equivalent fraction we know is 8. The part we don't know, this shaded little square right here, this is like our question mark. That's the part we don't know. We don't know how many eighths. We don't know the shaded part of our problem. Okay? So use multiplication to determine the relationship between the two known denominators. So if I look at my denominators, I have a 4. Because we're going to use multiplication, what would I multiply 4 by to equal 8? Right? That's how I'm going to find my missing link, right? That's how I'm going to find my missing piece. What number do I multiply by 4 to get an 8? Well, to multiply by 4 to get an 8, I would multiply it by 2, right? So I would do 4 times 2 equals 8. So we're going to use this relationship between our denominators to help us find the equivalent numerator part of our fraction. So if I'm going to multiply the 4 by a 2 to get an 8, that means I have to multiply the 3 by a 2 to get my numerator. So 2 times 3 is 6. So I'm going to need 6 scoops of that 1/8 teaspoon in order to have the same amount, because I know that in the original recipe, right, it would call for 3/4 of a teaspoon of fertilizer mixed with water, right? Sometimes they'll say 3 parts water to, 3 parts water, fertilizer to water. So you need to have a certain amount for each part. So that means that Karen needs to fill the 1/8 teaspoon measuring spoon 6 times to measure 3/4. So we're going to complete this picture. Thankfully, they've already, let me zoom you up a little more. We're going to complete this picture model. They've drawn the picture, so we'll use the circles, but if you had to draw your own, I would want you to draw rectangles. I know I sound like a broken record, but I have to keep saying it. So first we have, look, this one's broken up into fourths, so here's our 3/4. So we're going to shade in 1, 2, 3 of these pieces. And then this is our eighths, and we know we need 6/8. So we're going to shade in 6 of these pieces. 1, 2, 3, 4, 5, 6. And notice I try to leave the part that's not shaded the same and the part that is shaded the same in both figures, because that's going to really help you see that they're equivalent. So to justify our answer, this shows us that 3/4 is equivalent to 6/8. So sometimes we can use that missing piece, right? The missing, we know if we find a connection between these two numbers, what could we multiply by? Then that would help us know what we need to multiply our numerator by. So, oops, sorry. There goes my finger in the way. So sometimes we can also use division to find equivalent fractions. So I just want to, sorry, this book isn't not coming down or opening as much. So we've previously learned about factors, and a common factor is a factor of two or more numbers. So we can use common factors to divide the numerator and denominator to find an equivalent fraction as well. So we can also divide. We don't always have to multiply. So let's see how that works with this part. So to use division to find an equivalent fraction for 8/12. So we need to find the factors of 8 and 12. And what we're looking for is a number that they have in common. So if I'm counting, sorry, my computer is acting up a little bit here. So if I'm trying to figure out what are the factors of 8, what numbers do I multiply together to equal 8? Well, I know I can multiply 1 and 8 to equal 8. I can also multiply 2 and 4 to equal 8. So the factors of 8 are 1, 2, 4, and 8. Those are the only numbers, some way I can multiply them together to equal the number 8. So let's think about the factors of 12. I know I can multiply 1 by 12. It's an even number, so I know I can multiply 2 times 6. And I know I can multiply 3 times 4 to equal 12. So those are all the factors of 12. So now we need to figure out, well, what are our common factors? What are the factors that we have in common? Well, I can see that I have the number 1 in common, the number 2 in common, and the number 4 in common, right? Those are our common factors. So we need to use a common factor other than 1, because 1 would just give us the same number, right? If I were to divide 8 divided by 1 or 12 divided by 1 and 12 divided by 1, I would just get 8/12 again, because 8 divided by 1 is 8 and 12 divided by 1 is 12. So we're going to just pick one of them. Let's pick 2. So if I used a common factor and I divide 8 divided by 2, that's going to give me 4. And if I divide 12 divided by 2, that's going to give me 6. So that tells me that 8/12 is equivalent to 4/6. Now let's do a picture to see if that makes sense, if that works. So because we chose 4/6, we're going to need to break this one up into 6ths, okay? And to do that, because it's an even number, remember we can split it in half. So I'm going to find where their half is and split it in half here. So that way I know it's half is it's even and equal at halves. Then I need 6ths. So I need 3 on this side and 3 on this side. So I'm going to do about there and about there. Those are about the same size, right? And about there and about there. Don't those all look about the same size? Yeah. So now 8/12, I need to shade in 8 of them. 2, 3, 4, 5, 6, 7, 8. 4/6, I need to shade in 4. 1, 2, 3, 4. Look at that. They are equivalent. That can justify the answer by showing that picture, that they are indeed equivalent fractions. All right, so let's do some practicing with the check for understanding. Rachel spends 8/10 hour in the garden. William spends 4/5 hour in the garden. Do Rachel and William spend the same amount of time in the garden? How do you know? Well, let's see. If I want to see if 4/5 is equivalent to 8/10. What would I multiply 4/5 by to get to 8/10? What could I multiply 4 by to get to 8? I can multiply that by 2, right? And if I have to multiply that by 2, then I have to multiply my 5 by 2. And does that make sense? 2 times 4 is 8. 2 times 5 is 10. Yes, they do spend the same amount of time in the garden. And we know because here's where our work, right? We know because 4/5 is, and you multiply it by 2 halves, and that's going to give you 8/10. You could have also done division, right? We could have done 8/10. I'm just going to show you how we could have done that, right? What would we have to divide the top and the bottom by to equal 4/5? Well, 8 divided by 2 is 4. 10 divided by 2 is 5. Right? So these are the two ways. You could have explained it with multiplication and you could have explained it with division. Whichever one you feel comfortable doing. This, they want us to use multiplication. So we're going to use multiplication or division to generate an equivalent fraction. So we're going to make our own equivalent fraction. So we just need to make sure we use the same numerator and denominator to multiply by this numerator and denominator. So we can choose any number. Let's choose the number 5. I like 5s. 5s are good to multiply by. So 5 times 1 is 5. 5 times 4 is 20. So 1/4 is equivalent to 5/20. 4/8. So we're going to divide. So we need to think about our 4 and our 8. We need to think, what could we divide them both by? It needs to be a number that they have in common. Well, because they're both even, I know that they have a 2 in common, right? Even numbers always can be divided by 2. Always, always, and forever. So 4 divided by 2 is 2. 8 divided by 2 is 4. And that really is the only thing we could do, right? Well, no, I shouldn't say that. No, we could have done 4/4. Because 4 divided by 4 is 1 and 8 divided by 4 is 2. So that would be 1/2, right? So we could have done 4. But 2 works as well. 2 or 4. All right. So now we're on the on your own section. So if you want to do this part independently, you can pause the video right now, try it on your own, and then come back and check your answers, or stay right with me and do it along with me, whichever way you feel the most comfortable. Oh my goodness, Peter picks. I'm thinking of Peter pack a pick of peppers, right? We're going to start a tongue twister here. Peter picks 3/5 pound of tomatoes. Explain how you can write an equivalent fraction for 3/5. Use visual models to show how your fractions are equivalent. Well, if we have 3/5, we can see here's where our fifths are. So we would shade in 3 of them. Now, when I look at this picture, I can see that it's broken up into tenths, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we would have 3/5 is equal to something tenths, because this is broken up into tenths, right? Basically, we just split that 1 in half. So 5 times what is going to equal 10? 5 times 2, right? So if you're multiplying the bottom by 2, you have to multiply the top by 2. So 2 times 3 is 6. So we would need to have 6 of these shaded in. And look, 3 of those, 6 of these, they are equivalent. So 3/5 is equivalent to 6/10. All right, we're going to use multiplication or division to generate an equivalent fraction. So we're going to choose whatever we want to multiply by. How about we do 3? 3 times 2 is 6. 3 times 5 is 15. This is where knowing your multiplication facts and being quick with them, this is where it's easy breezy, right? This is where it becomes kind of, if you have them automatic, this is going to go fast. If you're still struggling with those multiplication facts, that's where you need to really be practicing them more and more. Make sure you're always getting that green light on reflex every day. If you have flashcards at home, or make flashcards at home and practice those. So now we've got our 3/4. We want to find an equivalent fraction of 3/4. We're going to multiply whatever number we want. How about we do 4? 4/4. 4 times 3 is 12. 4 times 4 is 16. So 3/4 is equivalent to 12/16. Now we need to divide. So we're going to have to look and see what number do these numbers have in common, right? If I think of my 6 and my 8, what numbers do they have in common? Well, again, if they're even, the easiest way to do it is to use a 2 because they're even, right? Because you know they're going to be easily divisible by 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. So that tells me that 6/8 is equivalent to 3/4. Now we have 5/10. Now, here's one. We've been dealing a lot with numbers that are both even, right? Here where we have an odd number and an even number. So now I have to think, what do my 5 and my 10 have in common? What number could I divide them both by? Well, I know that I can divide 5 by 5 and I can divide 10 by 5 and get a number, right? 5 divided by 5 is 1. 10 divided by 5 is 2. So that tells me that 5/10 is equivalent to 1/2. And one way I know that is because 5, my numerator, is half of my denominator. If my numerator is half of my denominator, then that number will always be equivalent to 1/2. You won't even really have to do this piece because you know that 5 is half of 10. Okay? Right, true or false for the statement. So let's look at these numbers. 1/4 is equivalent to 3/7. Is that true or false? Well, let's see. Can I multiply anything and get a 7? Or anything by 4 and get a 7? No, I can't. Nothing times 4 equals 7 because 7 is a prime number. So, and the other way I can look at this is 1 times 3 is 3. 4 times 3 is 12. That should be a 12. So this is false. 5/6 is equivalent to 10/12. Well, what do we have to multiply 5 by to get to a 10? We multiply it by a 2. Can we multiply 6 times 2 to equal 12? Sure can. So that one must be true. 8/10, is that equivalent to 4/5? Well, what do I have to divide 8 by to get 4? I would divide by 2, right? I'm going to put a little multiply. If I divide 10 by 2, I get a 5. So yes, this one is true. Number 12. There is 1/2 of a vegetable pizza left. The pizza had 8 slices. How many slices of the pizza are left? So, if we have a pizza, we know there's half of it left, right? Half of the pizza is left over. The pizza originally had 8 slices. How many slices of pizza are left? So let's see. We see that if half of the pizza is left and there were 8 to begin with, we know that there are 4 left. So this tells me that 1/2 is equivalent to 4/8 because 1/2 equals 4 times 1 over 4 times 2, which equals 4/8. And the last page, generate 2 equivalent fractions for the fraction. So we're going to be able to make our own, whatever we want to do. So I'm going to first start by, I'm going to multiply 1/3 by 2 over 2. So 1 times 2 is 2. 3 times 2 is 6. So if I multiply by 2, multiply by 2. What else could I multiply this by? I could multiply 1 times 3. 1 times 3 is 3. 3 times 3 is 9. So 1/3 is equivalent to 2/6 and 3/9. But 2/6 is not equivalent to 3/9. Okay, this is a little misleading how they have these equals. Just make sure you're realizing that it's 1/3 that's equivalent to both of those. These two are not equivalent to one another, but 1/3 is equivalent to both of these numbers. Okay, 3/5. Let's multiply by 2. 3 times 2 is 6. 5 times 2 is 10. So 3/5 is equivalent to 6/10. And then we can multiply by 3. 3 times 3 is 9. 5 times 3 is 15. So 3/5 is equivalent to 6/10, and 3/5 is equivalent to 9/15. And again, 6/10 is not equivalent to 9/15. However, 3/5 is equivalent to 6/10, and 3/5 is equivalent to 9/15. Just remember that. 10/12. We could, how about we divide for this first part? We could divide by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. We could multiply by 2. 10 multiplied by 2 is 20. 12 multiplied by 2 is 24. So 10/12 is equivalent to 5/6 and 20/24. Now in this case, because we divided and we multiplied, 5/6 actually is equivalent to 20/24 because you would multiply 5 times 4 to equal 20 and 6 times 4 to equal 24. But this is not very, it will not be the case if you're, it only is the case if you multiply or if you divide and multiply by the same number. And that's for a later time. But just, it's good to point that out. Okay, Victor installs tiles on a floor. He uses blue tiles for 4/5 of the floor and white tiles for the rest. If Victor uses 100 tiles, how many of the tiles are blue? So, we know that he uses blue for 4/5 of the tiles, right? And there are 100 tiles. So we need to figure out what number did you multiply the 5 by to get to 100, because you're going to have to multiply the 4 by that same number. So 4/5 equals, what would you multiply 5 by to get to 100? That would be 20. So then you have to multiply the top number by 20. 20 times 4 is 80. So 4/5 is equivalent to 80 100ths. So we can show that by, we would shade in 4 of these. And then we need to shade in 80. So what I'm going to do is, I know each one of these, because this is 100, 100 square, I know that each one is 10. So there's 10, 20, 30, 40, 50, 60, 70, 80. And we can see that the same amount is shaded in. So 4/5 is equivalent to 80 100ths. So out of 100 tiles used, 80 of them are blue. And finally, the table shows how much tomato juice each person drinks. Who drinks the same amount of tomato juice? Well, let's look at our numbers. We have 1/4. We have 5/20, and we have 3/12. So can we go from 1/4 to 5/20? Are those equivalent? Well, 1/4 equals 5 times 1 over 5 times 4, right? That would equal 5/20. 1/4, does that equal 3/12? Whoops, why did I make that so big? 1/4 equals, oh, I should make this bigger, I apologize. Shouldn't really do it on these lines. Then maybe I'd have more room. What are you going to multiply 1/4 by to equal 3/12? Can you do 3 over 3? Yeah, you can. So, who drinks the same amount of tomato juice? They all do. They all drink the same amount of tomato juice. Can we do 3/12? Or we can do, so we know that if 1/4 is equivalent to 5/20 and 1/4 is equivalent to 3/12, then they all drank the same amount. So they drank the same amount of tomato juice because 1/4 is equivalent to 5/20, 1/4 is equivalent to 3/12, so that means that 5/20 must be equivalent to 3/12 because those are all equivalent to each other. So they drank the same amount of tomato juice. All right. Okay, so you are going to do the independent work. You're going to do 11.4, the front and the back. When you're finished, make sure you return it to school. I need everything returned to me by Friday, the 16th, so that way I can get it all graded. If you are working on it Friday and you want to return it on Monday, I am okay with that because I'll have your next packet of work to give to you by Monday the 19th. But so that way you'll be able to pick it up then. But so if you want to wait and return it on Monday the 19th so you can pick up your next packet, that works as well. Just as long as I have it, so that way I can get it taken care of. All right, I hope you guys have a great rest of your day and week, and I will see you soon. Bye.